Hi there, my name is Henry Pereira. I'm a co-founder of Aquaponics, and today I will be taking you through this commercial 3D aquaponics system, a 3D design that we've done in SketchUp. So it should give you a good view of the inside, the outside, different sections. So let's get to it. As you can see here, it's a 30 by 10 meter tunnel or greenhouse, and what we've done is we've split it into two sections. The reason for that is because plants have different climatic conditions. The fish want warm climate, humid climate. The plants need more ventilation, and you need to be able to control heat in summer and the flow of air through the tunnel. For that reason, you'll see that on this tunnel here, we have the side flaps. You can easily roll up the flaps up and down. Also, the top of the plant section is in plastic, and the sides are in shade net, 20% shade net, with roll down plastic as well. So in winter you can roll down the plastic, in summer you can roll up the plastic and just leave the shade net, or you can even roll up the shade net as well to let ventilation through. Whereas in the fish section, here you'll see that it's completely blocked out from the plant section with a plastic divider, if you want to call it. There is a door that allows you to go from the fish section into the plant section. That's the basic of it. Now, as I said, this is a 30 by 10 meter tunnel, 30 meter in length, and the way we've divided it, this is about 4.5 meters. The fish section is about 4.5 meters in length, or 5 meters in length, whereas the plant section is 25 meters in length. So 25 plus 5 makes it 30, and the width is 10 meters wide from there to there. Let's now go through each section individually. I'm going to go onto a different scene. What I've done here is I have removed the whole tunnel so that you can see how it's laid out. And now let's go through this. I'm going to go through each individual component in the fish section. In this setup, you have two fish tanks, each measuring about 2 meters in diameter by 1.4 meter high. So that will give you about 4,500 liters per tank. That will be 9,000 liters total volume in these two tanks, in these two fish tanks. Keep in mind that with a stocking density of 30 kilograms of fish per 1,000 liters, you would only really be able to supply enough nutrients for half of these grow beds. These grow beds in total amount to about 110 square meters. So in able to supply enough nutrients for all the beds, you would have to increase the volume of your fish tanks to 20,000 liters in total. In other words, 10,000 liters on this side and 10,000 liters on that side. That would equate roughly to a diameter of 3 meters by 1.4 meter high fish tanks. Of course, you would then perhaps have to extend the size of the, or the length of the fish section to about 5 meters to be able to squeeze those 3 meter diameter tanks into the section. Also keep in mind that in a commercial system of this size, you would always have to supplement additional nutrients, because the fish and the fish food that you're feeding them will not be able to supply all the macro and micronutrients that the plants need. So things like potassium, calcium, magnesium, and iron would have to be added as a supplement over and above what you're feeding the fish. Here you have a sump which is below ground. Now the sump is the lowest point in the whole system. So the water from the deep water culture is fed back to the sump via this returning 110 mil pipe. Okay, and The fish tanks are the highest point in the system. So there are pumps inside the sump, water pumps. There you are. And that pump pumps water up into the fish tanks. Okay, into that tank and into this tank. Now, from the fish tank, there's a bottom-fed pipe there. You wouldn't quite do it like this, but you know, there are ways of having a bottom drain, bottom drain on the tank. Also, you could bring the pipe up and then out the side, as most people do. So from the fish tank, the water gravity feeds onto a radial flow filter, which is a mechanical filter. This filter separates the solids. In other words, any uneaten fish food, fish feces, any waste from the fish tank gets filtered out by this mechanical filter. It goes to the bottom. I'm not going to go in detail of what a radial flow filter does, maybe in a different video in the future, but there are many videos on radial flow mechanical filters and how they work. So yeah, the solids get separated, they settle at the bottom, and you then, what you can do, you open a valve at the bottom and let all those solids go through to a, what we call a mineralizer tank. This mineralizer tank is isolated from everything else, and with heterotrophic bacteria and aeration in this tank, the heterotrophic bacteria proliferate and they'll get rid of any solids. So uneaten fish food, proteins, carbohydrates, all that gets turned into ammonia, minerals, which you can then reuse in your system. So you can call the heterotrophic bacteria the decomposers of the bioworld. This is a biofilter. You would need a biofilter if you are doing a deep water culture system, as shown here. This is a deep water culture system, floating trays. And basically what a biofilter is a tank full of media that would be something like leca, lightweight expandable clay aggregate, or bioballs. Autotrophic bacteria, beneficial bacteria, nitrifying bacteria, would be sending up their colonies in this biofilter system here, in the grow media or in the biomedia. And what they do is they convert your toxic ammonia and nitrites into nitrates, which are then taken up by the plants. Without a biofilter, you're going to get a buildup of ammonia, which will kill your fish and, of course, not supply any nitrates to your plants. So it's essential to have a biofilter when you're going deep water culture or NFT system, nutrient film technique, the pipe system. If you're going to have a few of these beds as ebb and flow with grow media, then you don't really need a biofilter because the grow media beds will act as a biofilter. So in every system as well, you would also need aeration. So here you can see an air pump, and that would be supplying air. Let's just try and get this out here. So there's a water line and there's an air line that goes down there. And this is supplying aeration to the fish tanks, to the biofilter, to the mineralizer, and also you would need aeration in the deep water culture beds. You can see the air line goes in there, and if you go take a dive into the water, you'll see the air line going all the way down the channel with your air stones tapped off every 1.5 meters or 1 meter. The more air stones, the better, because if you don't supply air or dissolved oxygen in a deep water culture system, then you're going to get root rot. So air is essential in deep water culture. The most challenging part of a build like this is going to be the grow beds. You want to build these grow beds in the cheapest material possible. So you're going to have to decide whether it's going to be in concrete with sealer, if it's going to be wood frame, if it's going to be fiberglass, and I'm going to show you some examples just now. Keep in mind that when you go farming, always try and keep your capital expenditure to as low as possible. The higher your capex, the more difficult it's going to be to pay off and make it financially viable. So always aim to go spend as little as possible on the build itself. So now I'm going to show you the different types of grow beds that you could build. This is our system in Johannesburg. You can see what we've done here. Because this is like a show area, we've basically built it in brick to be long lasting, and then lined it with HDPE plastic. It's quite expensive to build in this way, but we did it to last and as a showcase. We also have we've raised it by 400 mil, so these are the deep water culture channels. And then to the right there, you'll see the raised beds for flood and drain. So they're even higher than your deep water culture beds. Yeah, so this is an option to do it in brick with lined with plastic, HDPE plastic, which can be pretty expensive. This is something else that we've done. We've gone for a cheap option here. We've used wood frames from pallets and lined it with PVC. So as you can see, just as effective. 400 meter deep. So these are actually 380 millimeters deep. And in the background there, you can see our brick deep water culture beds to get a good comparison between the brick ones and the ones in wood. This is our new product, fiberglass beds. They are expensive, but it cuts down on labor substantially, because all you need to do is make sure they're level, you interconnect them. We got different lengths. So we have a 1.8 meter by 0.8 meter bed by 300 millimeter deep grow bed. We also have a 2.5 meter long bed by 1.2 meter wide by 300 millimeter deep. As you can see in this picture, some have been turned into media beds, flood and drain media beds, which flows back to your sump, and the other ones are deep water culture. You can see the air stones on the right there, every 1 meter, aerating the deep water culture channels. Here is another view of the fiberglass beds in a 30 by 10 meter tunnel. These beds are 5 meters in length, by 1.2 meter wide, and you can get this in 250 millimeters or 300 millimeter deep. These are actually 300 millimeters deep. So yeah, it fills up a 30 by 10 meter tunnel quite nicely. They also stand on cinder blocks or cement blocks, so it's not very expensive to put that up. And the nice thing about them being raised off the ground like that is that it's much easier for you to harvest. Rather than having to squat down, you can stand up and harvest your vegetables without too much strain on your back. Also enough room space in between them so that you can harvest from either side. You don't want to be stretching more than 500 to 600 millimeters across the grow bed. Here's another installation with these fiberglass grow beds, and this is another customer of ours that decided to build these grow beds also in brick and mortar. These are more of a drip irrigation type system where you have the grow beds full of cocoa peat and then drip lines going all the way down. And all they do here is there's no recirculation. The water that comes into these beds to irrigate the plants does not overflow. You just feed enough water to nourish the plants, and that's it. There's no overflow. So in our system in Johannesburg, we should have designed the same way as you've seen previously in a 3D design. But this is a few years ago, and what we opted to do is have one tunnel on the left there. You can just see part of it, just for the fish, and the tunnel on the right just for the plants. You can see the plant tunnel's got plastic on top, On the sides, it's got 20% shade net and deep water culture beds as well as flood and drain beds. So there's an inside shot of the plant tunnel. There is an inside shot of the fish tunnel. So in the fish tunnel, you can see that we have 4 tanks, 4 3,500 litre tanks, fish tanks. We then have your radial flow filters on the side. You can see the mineralizer in the forefront there, and we also have the biofilters. Yeah, although we don't really need the biofilters because our media beds in the plant tunnel are enough for the biofiltration. In this tunnel, we also have the lowest point, which is a sump, where the people in the background there, they're looking at the sump right now. There's another view of our plant tunnel, and yet another view. In the forefront, you see the wooden frame grow beds, and in the background, you'll see the grow beds, deep water culture grow beds that have been built with brick and mortar, and on the left, your raised grow beds, ebb and flow, or flood and drain grow beds, which are at a higher level than the deep water culture beds. All these then flow back to the sump in the fish tunnel next door. For those of you that have watched my other video on aquaponics split system or hybrid system, we can easily change or convert this setup to a hybrid system. Basically, what you would do, you would just bring a pipe up there, across into there. You could put a valve there to close and open, and then you'd also put some valves there and valves there. So for example, if you wanted to bypass the fish tanks for some reason, in other words, you don't have fish, or you want to convert this into a hydroponic system, what you would do, you'd close these valves here so that the pump would pump up this pipe. You'd obviously open this valve here. It would come down into the plant beds and of course feed back to the sump. You would therefore completely eliminate your fish tanks and run it as a hydroponic system. You put hydroponic nutrients in here and keep your system going hydroponically. If you wanted to run this as a aquaculture system, for example, if you didn't have any seedlings and you didn't have plants, you just wanted to run it as an aquaculture system, what you would then do is you could put a valve there to shut this off, and then you add a pipe, different color here, from there back into a sump. So what would happen there is you would close this valve here, the pump would pump to the fish tanks, these valves here would be open, this one would be closed, the water would flow into the fish tanks, into the mechanical filter, into the biofilter, out that side, back into the sump. And the same would happen here. Pump would pump water up into your fish tank, into your mechanical solid separator filter, into your biofilter, down the purple line, back into the sump. So nothing would be going through to the plant grow beds. So that's a simple modification to the setup to make it into a hybrid system. We can use it as aquaponics, as hydroponics, or as aquaculture. That would be hydroponics. The purple will give you aquaculture, and of course, if you open them all up, it would then be aquaponics. Let's have one last fly through inside the tunnel. If you've liked this, guys, please give a thumbs up at the bottom and subscribe to our channel, and watch some of our other videos, and we have to share more videos going forward, and I hope you've learned from this one. Thank you for watching.